Hi everyone, my name is Violetta Peterson, and today I will be doing a demonstration on Project 2 of the Operating Systems Summer 2017 class. And the objective of this project is to create a portable file system with linked allocation method to allow the user to interact with it using the command line interface. So first I will do a little bit of the logic behind the project, and I will follow up with the actual demo. So let's get started. So I created my project in C, implemented it on Linux, and for two reasons. I wanted to explore the Linux a little bit more, and I also wanted to learn C. The project proved to be challenging, but also fun at the same time. So let's talk a little bit more about the components of the actual program. So on top of everything, we have the command line interface. And the command line interface allows the user to interact with the portable file system, and it allows the user to use various commands to access files, read files, copy them, etc., etc. The next component we have is the actual PFS file, and that's kind of the simulation of the disk. And in it, we have a formatted blocks that contain bitmap, the file metadata, that's our file control blocks, and the actual data. Furthermore, we have a directory, and that actually resides in the program itself, so in the memory. And it allows, so it holds the bitmap and the file metadata, and it allows us to easily access that metadata, search for a specific file we want to run the operation on, and be able to use the bitmap to find how much space we have left and how much space has been allocated already. And finally, we have a set of commands that the user can perform, and we'll go into more detail on those as well. So let's talk a little bit about the actual PFS file and its formatting. So in our PFS file, the first block is taken up by the bitmap, and the bitmap initially is 1 followed by a bunch of zeros, indicating that the first block is allocated to data while the rest of the blocks are free. And in this project, I actually decided not to add all the file control block pointers to the super block. And instead, I did the following. So we have a block dedicated to the FCB, a bitmap showing that it has been, that space has been allocated. And I used a delimiter to identify the file control blocks. So my delimiter is actually #FCB. So unfortunately, if you attempt to insert a file that contains #FCBs everywhere, the PFS file will become corrupt and it will end in a horrible disaster. But I'm counting that does not happen. So our file control block has formatted file metadata. So we have the block that the FCB resides in, the file name, its size, date and time of creation, and then the start and end blocks for the data. So when we insert the data, and again, they look contiguous for the point of this presentation, but they do not have to be. So when we insert the data, each block contains 254 characters of the data and 2 characters dedicated to the pointer of the next block. So for example, we have a block that says 10 data, and 10 would actually point to the next block in the sequence of the file, until of course the last block. And the very last block of the sequence would actually contain the pointer 0, 0. And that way the PFS program will know that this is the last block, and here's where we stop. So talking a little bit about the command line interface, it's formatted in the following way. We have the command, which links to a certain method or function in the code. We have the parameter, and this could be the file name or the file or the PFS file name. And finally, we have optional remarks. That's for the put_r command, and that allows the user to enter 254 characters of code. And actually, remarks creates its own block, so it does not. So it appends the file by with an additional block. And you can, of course, insert several remarks to your file. So the directory I implemented as an actual like C language structure, and uh, so bitmap is actually represented by an array of characters, and those are zeros and ones. And the program itself can easily look through those to see if file has been, or if block has been allocated, or it's free. And on top of it, we have the file metadata. And the way I implemented that is actually create a structure for the FCB. So to contain the file name, size, time, start block, end block, and inserted an array of those FCBs into the directory itself. So the directory points to an array of FCBs, and each FCB contains certain information. And finally, let's talk a little bit about the project components. So we have, the commands. So we have open PFS, and what it does is if the FCB file or our disk does not yet exist, it creates a new one and populates it with a brand new bitmap in the first block. But if it already exists, it actually parses that file and inputs the information into the directory. And for the put file, what it does is it goes into the directory, searches the bitmap to see if enough space is available. Then it also searches the file metadata to see if the file already exists in the directory. And if it does not, it goes ahead and adds the information, so updates the bitmap and the file metadata with a new file, and then goes into the PFS file, updates the bitmap there, and inserts the file control block, and then adds the data. So for the put our file remarks, we actually look into the directory to find the file that we want to append, see if there's a block we can dedicate to the remarks. And if there is, keep note of that block, go to the end block of the file metadata in PFS file, update the pointer to the remarks block, and then insert the remarks block with a 0, 0 pointer indicating that it's the last pointer. And the get file, what it does is it goes into the directory, searches for the file, finds the file, goes into the PFS file, locates it, and then simply copies it over into the new file on user space. The remove file does something similar, so it goes into the directory, finds the file, and then goes into the PFS file. And there it nulls out the file control block and the data of the file we were trying to remove. So when it does, it actually replaces it with white space. The directory is very simple, so it actually simply just goes into the directory and displays the information from the array of FCBs. The kill command simply deletes the PFS file we specified, and the quit allows the user to safely exit the program. So now that we got the logic down, let's actually take a look how the project works, how the program works. Okay, so we are currently in the Linux, in the Debian distribution, and I have my executable file saved on my desktop. And I also have a version of a PFS, so a disk. So let's run the executable file and open that disk to see what's inside. So when we run the directory, we can see the file names that are inside the PFS file. We have the sizes of those files, the created date and time. So what I'm going to do is I'm actually going to extract my file from this PFS onto my desktop. I'm going to open or create a new disk, and I'm going to add that file into it. So let's see how that would work. So first I'm going to do get my file.txt. And as you can see, it does not change the directory. Now I'm going to remove that file from the directory, so it's no longer there. And what I'm going to do is I'm actually going to create a new PFS. So now that I've created a new PFS, this is my current working file system. So it's no longer your PFS, it's my PFS. And if we check the directory, we can see that it's totally empty. And actually, if we take a look inside, we can see that's the only thing in it is the bitmap, and that's it. So let's run the executable again, and let's upload that file into my PFS. Oops. Okay. So now if we check the directory of my PFS, we can see that the new file has been uploaded. So again, let's take a look inside. So here we have the bitmap that has been updated with the allocated blocks. We have the file control block pointing to start block 2 and block 9, and it resides in block 1. And block numbers start at 0, so that makes sense. And furthermore, we have data blocks. So a data block begins with a pointer to the next block, and then data. And then we can see the pointer to the next block. So for example, this is one block, and it's 254 characters for the data and 2 characters for the pointer. And then the last block is actually ending with 0, 0. So let's add some information to this file. So let's put remarks my file. And remarks have to be enclosed in double quotes. So we can say okay. So if we check the directory again, we see that the only thing changed is the size was actually updated, but everything else stays the same. So let's take a look inside now and see what's going on inside the PFS. So when we do that, we see that the last block of our file was previously 0, 0. Now it's actually pointing to our remarks block. And now our remarks block is pointing back to the super block. So the remarks block is now the last block of the sequence. Okay. And another thing we can do is we can actually say that maybe we no longer need this disk. So we can just go ahead and kill my PFS. And it says my PFS has been removed successfully, and we can see that it's completely gone from the desktop. And that wraps up for project 2. Again, if you have any questions, you can definitely email me or reach out to me, and I'll be happy to answer them. And thank you so much for watching. Have a great day.